Welcome back. This is Middle School Math with Dr. K. This is the second video of a three-part series on basic angle properties to be familiar with. In this video, we're focusing specifically on vertical angles. Now, if you haven't already, you should really check out the first part in this series. Part 1 focuses on naming an angle and then recognizing and using the ideas of complementary and supplementary angles. That video is a lead-in to today and will help you better understand the work that we're doing, so check that out first. If you're ready to move on, keep watching. Let's talk about vertical angles. Vertical angles are created by lines that intersect. The definition says they are non-adjacent angles created by two intersecting lines. What does that mean? It just means when two lines cross, they form four angles, and the ones that are not adjacent, that don't touch each other, or you could say they are across from each other, those are considered vertical angles. So in this example, ABD, angle ABD, and angle CBF are vertical angles. In this case, and in many cases, there are actually more vertical angles. For example, these two angles right here would also be considered vertical angles. That's angle CBA and angle DBF. Now, what's interesting about these kinds of angles is that they're congruent, which means they have equal measure, and we're going to use that as we solve problems moving forward. Here's an example of when we might use the idea of vertical angles. This question asks us to find the measure of angle ABC. So let's look at that. Angle ABC is here, and it's created by two intersecting lines. Anytime you have two intersecting lines, there are going to be some vertical angles, and that's an important point to focus on. In this case, the angle that is vertical with angle ABC is angle DBF, and that means those are congruent angles. So I could say here that the measure of angle ABC is 102 degrees. How I write that is I use an M for measure, an angle sign for an angle, and I say the measure of angle ABC is equal to 102 degrees. Let's try another. Here's a similar problem that's a little bit harder, just a step harder. Now this one asks us to, instead of finding the measure of an angle, to find the value of a variable. Now when I look at x, I see it next to a 5, and I see that that's angle CBF, which is right here. When I'm looking at this picture, I also see the angle 95, and that tells me that these are vertical angles. They are non-adjacent, and they're created by intersecting lines. When that's the case, I know that these two angles have to be equal to each other. They have to have the same measure. In fact, we call that congruent. The shape is congruent, and the measures are equal. Now, in order to solve this, I can say that because they are vertical angles, that 5x has to equal 95. Once I have something like that written, an equation, an algebraic equation, I can solve for x using the same properties I would have used in solving any other equation. I divide both sides by 5, and that leaves me with x equal to 19. I can even check my answer by double checking that 19 times 5 gives me 95 degrees. That's how I know I've done it correctly. Here's a problem that looks pretty intimidating. In fact, it's using the same information we just used. We're just adding on more pieces at this point. Now, this problem specifically says A, C, and B, D are straight lines. You'll see these symbols. That's just referring to them as lines. That helps us know they aren't angles or arrays or any other shape. They are lines. It even tells us they're straight lines. The reason why that happens is because if these two are straight lines, we're going to have some vertical angles. Now, it does not tell me that these other two rays create a straight line, these ones right here. So that tells me that those will not really have much to do with any vertical angles. So let me get rid of those so we can focus. Now, the idea is to find the values of x, y, and z. So we have three variables. The first thing I want to do is look for any vertical angles that I might use in the process. For example, I see that 60 and x are created by the straight lines, and they are non-adjacent angles. That tells me that they are vertical angles, and that x has to equal 60. One problem solved. From there, I'm looking for any other information that I can manipulate. And this is going to pull from that information in video 1, where we talked about supplementary and complementary angles. I say that because all of these angles all the way around should equal 360 degrees. Now, while that's good and useful and helpful, I still have 2 variables, so I'm really looking specifically at half of this picture. Now, because the entire picture equals 360 degrees, I know that half of the picture has to equal 180 degrees. So I've already got 2 pieces of information on that half. I've got that one angle is 60, I know another angle is 70, and the last angle is y. Altogether, those angles have to equal 180 degrees. So what can we do to solve that? The first thing I see are like terms, so I'm going to combine those to become 130 plus y equal to 180. From there, I can subtract 130 on both sides, and that tells me that y is equal to 50. Already, I've found 2 of my variables. In fact, I can use that same idea on the other side to solve for z. I know that I have a 30-degree angle, and a 60-degree angle, and a z. Altogether, those 3 angles should equal 180 degrees. Now, 30 plus 60 gives me 90. And when I subtract 90 on both sides, that tells me that z is equal to 90. In this problem, I have used multiple properties. I've used vertical angles, I've used angles adding up to 360 and angles adding up to 180, and all of these properties together gave me all 3 answers I was looking for. This is the last problem I want to show you. I think this problem is very interesting because it gives you a lot of information in the words and much, much less information in the problem itself. This problem tells us that AD and BE are straight lines. So one thing I'll do is start by looking specifically at those straight lines. I see that they are creating some angles that could potentially be vertical angles. It also tells me that angle AYB and BYC are complementary angles. That's these 2 right here. That's information that's interesting to me too. I know that complementary angles equal 90 degrees. Then it asks me to find the value of every angle in the image below. That means everything that doesn't already have a value needs one. So let me start with the idea of straight lines. So I'm looking here. I see that I've got straight lines, which tells me I should have some vertical angles. When I check my picture, these 2 angles, angle BYA and angle DYE, are vertical. That tells me that angle DYE has a measure of 18 degrees. The next thing I'm going to use is this idea of complementary angles. Now, complementary angles have to add up to 90 degrees. What that tells me is that if I take 90 degrees and I subtract the 18 I already have, which leads me to 72, that's the measure of angle CYB, 72 degrees. Now I need to find a way to calculate the other angles in this picture, and that's where I'll pull from that last video again. I know that I have multiple angles that form a line, form what we sometimes call a straight angle, like these 3, which means they need to equal 180. Now, one of the angles is 72, one is 18, and the other one I'm going to call X. Those together need to equal 180 degrees. Well, I already know that 72 and 18 form complementary angles, so those equal 90. So I can solve this relatively easy and find out that X has to be equal to 90, making this a 90-degree angle. I'm actually going to use that same property on the bottom half of this line, although now that I have 2 angles, it's actually quite easy. I'll call this angle Y, and I know that 18 plus Y needs to equal 180 degrees. Now, like I said, this is a much smaller equation, easier to solve. All I need to do is subtract 18 from both sides. That tells me that Y is equal to 162, and this angle is 162 degrees. Okay, so we have covered a wide range of material in this video. We've talked about vertical angles, what they are, and the fact that they're congruent, which means they have the same measure. We've reviewed complementary angles, supplementary angles, angles that add up to 360, angles that share a vertex, adjacent angles, lots of information here. I hope this helps you better understand how all of these angle properties come together to solve a more intricate problem. If you're interested, hit subscribe, like the video, and you can see more of the material that I'm posting, all related to middle school math. Otherwise, thanks for being here. I appreciate you, and I'll see you next time.